What's poppin', dogs? Mr. Allen here talking reference angles in this video, which means you've likely just started your trigonometry unit or perhaps just reviewing for your test. Either way, I got you, bro. All right, determine the reference angle for each. So reference angle is just how far away we are from this x-axis here, okay? Never the y-axis, just the x-axis. And generally we can think of it as almost like a bow tie type shape based on where my terminal side of the angle is, okay? So for this first one here, for example, we got 135. That would land me over here. My terminal side would be right here. Now, how far am I away from 180 degrees? That's the angle that's right here. Well, if I took 180 and subtracted 135, I get 45 degrees. That is my reference angle for 135. And you'll know 135 later on. It's a very common angle, okay? It's one of our special right triangle type angles here that you'll see throughout the trigonometry unit. All right, 200. 200. Where's that going to land? Well, if I were to draw this up, okay? If I were to draw this up, I'm going to go a bit past 180 this time to my terminal side. Well, how much past 180 am I going? I could do 200 minus 180, which we all know is going to be 20 degrees. Nice. Okay. So perhaps we see this bow tie forming. Maybe not, because I didn't draw necessarily the triangle aspect. But if I were to draw, say, this back as like a triangle, draw this, oops, as a triangle, we've got like this part right here forming. Okay. So the lovely bow tie of trig. Hoity-toity. Okay. 310 degrees, man. 310. All right. Let me draw it up. Show the rotation. You won't always have to do this, right? I'm just doing this right now, especially if it's like the first time you've seen this, okay? 310, I'm going to go, woo, not quite all the way around. How far am I from going all the way around? Well, if 360 degrees is all the way around, I'm stopping 50 degrees short here. So if I did 360 minus 310, oops, that is 50 degrees. That is my reference there, 50 degrees. And now we've just formed this part of the bow tie. Excellent. Wonderful. Wonderful. I don't know if I'm going to get all the bow tie, but hopefully you can kind of see each piece forming there. 240. 240. All right. I'll stick with blue. So for 240 degrees, I'm going to go how far past the 180? I'm going to go 60 past 180. 240 minus 180 is 60 degrees for my reference on that one. Nice. Excellent. Wonderful. How about 500, negative 500. Oh my goodness. Negative 500. What the heck do I do there? Well, if it's negative, this is what happens. I start by rotating down. This is negative 360. And then I'm going to need to go how much more? Negative 140 more. So, whoop, landing over here. So now, how far am I away from this guy right here, which would be our negative like 180 here, right? I went an extra negative 140. So now I'm 40 degrees away here. So let's see here. I'll just put 40. There we go. So 40 degrees would be my reference. So it's always about how far am I away from the x-axis, okay? How much further do I need to go in degrees or radians to get to that negative 180 or positive 180, 0 or 360, whatever it may be? How far away from 180 or 360 or 0 am I? That is my reference, okay? It's never to the y-axis. It's always to my x-axis. One more here in degrees, 400. We got degree reference angle for 400, all right? Reference angles for 400, Jeopardy style. 400 is going to whip around once. That's 360, and then 40 more. So that means that 40 degrees here is my reference. I had to go 40 past the 360 full rotation, right? 40 past my x-axis, 40 past 0 degrees there. However you want to look at it, I'm 40 degrees away from the x-axis, so 40 is my reference. That's this guy right here. I think we got them all. We did. We got them all here, guys. We got the triangle right here. So we got the first quadrant bow tie, the fourth quadrant, the third, and the second. All four of them, yes, right there to form that wonderful little bow tie. All right, down here, radians. Radians are kind of scary, okay? They're kind of scary, but there's something that's real nice about radians, okay? When we're dealing with the nice, with our normal like trig ones, because you're going to evaluate with these later, the denominator gives you your reference, okay? My reference here is pi over 4. That's it. Okay? And I'm going to draw it up here real quick. 3 pi over 4. Well, this right here is pi, or 4 pi over 4. I'm going to be 1 pi over 4 away from being all the way to 4 pi over 4, right? One more from 3 would give me 4 pi over 4, which would give me pi. So my reference here is pi over 4. Over here on this one, if I do a negative 5 pi over 3, 6 pi over 3, negative 6 pi over 3, would give me the full rotation, right? I'm 1 away from that. I'm pi over 3 as my reference. Away from that. Nice. And 11 pi over 6, same dealio here, guys. I think you can actually fit it right here. 11 pi over 6, well, 12 pi over 6, 12 pi over 6, that's 2 pi. That's the full rotation. I'm 1 pi over 6 away from that. 1 pi over 6 is my reference. So with radians, just deal with my denominator there for the nice ones, right? The over 3, the over 4, and the over 6. That's my reference. It's super helpful. It's super quick. So there are advantages to radians. I know you're probably just getting into radians, converting from degrees to radians. You're like, bro, what's with these radians, man? Why do we have these radians? Why don't we just stick to degrees and be normal? Radians have their place. They are super nice once you get used to them, but it does take a little getting used to. Hopefully that helps, though, and you're rocking your reference angles at this point and just having a dope time getting tricky with it, because it's just getting started here. Tons of trig to learn. See you later.